What do you call an app with no offline support? Useless. Welcome back, viewers. Today I want to talk about offline mode. Now, offline mode is one of those features that really distinguishes apps from websites. Apps like Spotify and YouTube that allow you to download content for offline are lifesavers in situations where you're left without an internet connection. But have you ever used an app that supports offline mode and still been locked out with a spinner or loading wheel? This is truly one of the most frustrating things about using mobile devices. So why does this happen? Well, basically, it all boils down to a misconception in a framework called reachability. Now, reachability provides real-time information about whether or not an internet connection is available, whether or not it's over a Wi-Fi or cell towers, and whether or not it can reach specific servers. The mistake developers are making is assuming that the presence of an internet connection means that the connection is usable. If we think of the internet like a faucet and your app like a swimming pool, just because the faucet is on does not mean that we are going swimming anytime soon. What these developers are doing is effectively forking the data loading process. If an internet connection is available, then they go straight to the web server to get the data. If there's no connection, then they grab it from the cache. Seems reasonable, except when the internet connection available has very little data coming through. This is like filling a swimming pool with an eyedropper. So how can we do better? Well, we're gonna get there, but first we need to build an app that has an offline mode. To do that, we're gonna build on some skills we've used previously, like interacting with web servers and building table views, but we'll add the ability to cache the response from the web service API. That way the app can decide when it loads, whether to load from the cache or from the internet connection. And to make it super clear where it's getting this data, we'll add a loading view at the top that will display when it's loading data and whether or not it's loading from the local cache or the remote web service. Okay, let's get started. Create a new project in Xcode, a single view app, name it whatever you want. We'll start in the storyboard. Delete the view controller it comes with so we can start from scratch. Grab a blank view controller and drag it into the storyboard. Go to the fourth tab of the inspector and mark it as the initial view controller. Then on the third tab, assign it to the view controller class. We're going to start with the loading view. Drag and drop a basic UI view at the top. Using this ambiguous little button down here, assign constraints of 0 to the top, left, and right side, and then constrain the height to 60 pixels. Then set the background color to gray, or another color if you wish. Find an activity indicator view in the elements list and drag that onto our loading view. Add one constraint to the left-hand side of 20 pixels, and then another centering it vertically. Check this box to make it hide when stopped, which is usually a good idea when working with activity indicators. Next, find a label and drag it next to the activity indicator. Constrain the label to the activity indicator by right-clicking and dragging onto the activity indicator. Select horizontal spacing. Then select that new constraint and tweak the constant to exactly 20 pixels. Do the same thing again, this time dropping to the right side of the label and select trailing space to container. Add a constraint to center it vertically as well. Set the text to loading and tweak the font to whatever looks good to you. I like Helvetica Neue Light at 20 pixels myself. Now find a table view and drag that onto our view controller and drop it under the loading view. At this point, you might be wondering why we're using a table view and not a table view controller. It's simple. Table view controllers expect the table view to take up the entire view. In our case, we need some extra space for the loading view, so it's better we use a normal view controller. Add constraints to the table view. Start with 0 for the left, right, and bottom, and then by right-clicking and dragging onto the view, not the loading view, select top space to save area. Select that constraint and tweak it to exactly 60, the same height as the loading view. We will be able to animate this constraint in code so the table view will cover the loading view when the app is not loading data. Next, we need a prototype cell, so find a table view cell and drop that on the table view. In the fourth tab of the inspector, set the identifier to country cell. Now it's time to wire these elements to code. Open the assistant editor and find the view controller class if it's not already selected. Right-click on the table view and drag it into the code. Let go when you have a blue line and name the outlet table view. Do the same thing with the activity indicator and the label, naming them activity indicator and activity label respectively. Lastly, find the constraint for the top of the table view. Right-click on that and drag it into the code. Name it table view top space constraint. Let's preview this in the assistant editor, see how it looks. Portrait mode looks fine. Let's add another iPhone 8, which will default to landscape since portrait is already displayed. Looks good. Our constraints are holding up nicely. And now for some real programming. Close the assistant editor and open the view controller class. Create an enum at the top which will define 3 distinct states for the view: inactive, loading local, and loading remote. You might recall how we used a boolean in previous episodes to indicate whether a view is active or not. Well, you can think of this enum like a 3-sided boolean. Next, we will add a property called state of type ActivityState. We will add a didSetObserver, which is how we will handle changes to the state and update the loading view accordingly. If the state is set to inactive, we will hide the loading view. If it isn't inactive, or more to the point, if it's active, we will reveal the loading view, animate the spinner, and set the label accordingly. The text of the label will differ slightly based on whether the state is loading local or loading remote. In viewDidLoad, let's set our state to loading local and then wait 2 seconds and set it to inactive. That way we can see if we got the code above correct and test the animation. Alright, that worked great. Now let's verify that loading remote works too. Excellent, we're making good progress. Delete that test code and let's jump into the terminal app to prep some CocoaPods. If you're new to this, feel free to go back to episode 7 where we explain all about CocoaPods. Making sure you're in the same directory as the Xcode project, type pod init and hit enter. You'll notice this created a new file, the pod file. Back in Xcode, right-click in the navigator pane and select Add Files. Find the pod file and add it to the project. Then go into that file and add 3 pods. One for AlamoFire, one for SwiftJSON, and one for Reachability Swift, a handy wrapper for Apple's Reachability framework. Save that and close the project. Back in Terminal, type pod install, and then open the newly created XC workspace file it directs you to open. You should now see a new section for pods with the 3 pods we added inside. Go back to the viewController class and import these pods. You might need to force Xcode to build with Command B to get these modules to autocomplete. Now add a property for reachability of type reachability, then initialize it in viewDidLoad. Next, we need to create 5 new functions that we will fill in throughout the course of this episode. First, load data, then load from remote server, load from local cache, cache data with an argument for data, and display data with an argument for a JSON array. Let's go ahead and call load data from viewDidLoad. Then, in load data, we will check for the existence of a connection like this. For the record, this .none is also an enum. You'll probably start to see that enums are used a lot in Swift. Here's where we will do what other developers are doing. Fork the data loading. If there is no connection, then load data from the local cache, and if there is a connection, then load from the remote server. We're also going to tell this view controller to listen for notifications from the notification center, letting us know that the app has been brought to the foreground. We will call load data when it is. This just makes the app a bit more usable. We don't have to force quit it to get it to refresh. Anytime you do this, you have to mark the target function with this @Objective-C compiler flag. On to the next function, load from remote server. The first thing that function will do is set the state to loading remote. Then we'll use the AlamoFire pod to download the contents of the web service URL. But first, we need to put that URL in the code as a constant. This is literally the easiest and most common AlamoFire snippet you'll ever see. All it does is call the URL the same way a browser would, and then using this function response data, it passes the data to you in a closure. Remember, this closure is code that will not run instantly. It will only be run once the web service call is completed. In the closure, we access the data value and convert it to JSON using this uppercase called a JSON, which is provided by SwiftJSON. .ArrayValue simply means we expect the value of the JSON to be an array, which it is. Then we'll pass that JSON array to the function displayData. Lastly, we'll set the state back to inactive. Which brings us to display data. Displaying the data will require a data property for the items to display and implementing the tableview data source functions. Inside the display data function, we will use the response from the web service call, which is an array of universities as dictionaries. We could just display the list of universities, but that would be boring. So instead, we're going to learn some new skills like modifying arrays and dictionaries. Each university dictionary has a country attribute. We'll use that to populate an array of unique country names. There are many ways you can do this, but this is the easiest. It's not necessarily the most performant, but for now it will do just fine. Finally, we will set our unique array to the countries property and then call reload data on the table view, which will call the data source functions, so we better implement those. Don't forget to declare the classes conforming to the table view data source and delegate, which will help with auto completion. Now is also a good time to make sure we connected those in storyboard. Looks like somebody forgot. Now the three little methods you'll see all the time with table views. First comes number of sections. For that we'll return 1 as long as countries is not nil, which it will be in startup. In that case it's 0. Next comes number of rows in section. For that we will return countries.count. Last in our data source functions is self a row at index path. This code is fairly boilerplate. We simply set the text of the default text label to the item in countries, which is an array of strings. For good measure, I always like to fill in did select row at index path like this, which keeps a cell from looking permanently selected. Now we should be able to run it. Cross your fingers. Go! It's not HTTPS, and the iOS SDK doesn't like that for security reasons. I'm just going to quickly add an exception for this domain so we can keep moving forward. Make sure to go back and watch episode 7 if you get tripped up on any of this. Now we'll run it again. No need to cross your fingers, it's gonna work. Alright, that was fast. Let's run that back so we can see it again. Okay, we're almost done. Just 2 more functions left to implement. We'll add a call to cache data in the web service response closure and then implement that function. We'll need a file name for our cache. Let's put that up at the top under the web service URL. Name it something long and descriptive. Writing data to that file is fairly easy. We use the file manager to get a reference to the caches directory and append the name of our cache file to it. This code is very boilerplate, so don't be intimidated. The only thing we need to worry about is that data writing can throw an error, so we need to catch that. For simplicity, we'll just print to the console for now. We can also print the number of bytes written to the cache if we want to be really smooth about it. Next, we will implement load from local cache. Just like in load from remote server, we first set the state to loading local, and then we do nearly the same thing as in cache data, but instead of data.write, we do capital data contents of, which marshals the data into memory, and then we can parse it as JSON just like we did in the response from the web service call. How cool is that? Now that we have an app with offline support, let's test it out by leveraging the developer pane in the iOS settings app. We'll use the network link conditioner to throttle the internet connection down to one that mimics the New York City subway with very few bytes coming or going. Let's load our app and see how it handles this scenario. It's loading from the server. Still loading. Still loading. Still loading. Okay, let's go fix this. So how do we optimize this? Well, there's no harm in trying to load from the cache even if it's empty or the file doesn't exist. So let's do that first thing in load data. Then, if a network connection is present, go ahead and run the web service call, which will also update the cache and refresh the table view. Loading from the cache happens nearly instantaneously, so to give it enough time for us to see the label, let's delay the call to load from remote server by 2 seconds. Alright, now we're ready to test this out. Okay, now let's load our optimized app and see how it performs. It's loading it, wow. Okay, we have content already. It's loading from the server anyway, but we don't really care because we can use the app right now. I don't know about you, but I feel a lot better. That's all for today. If you like this video, you know what to do. If you're new here, go ahead and subscribe. Thanks for watching, and see you next time.